Hello, welcome students once again to this C programming lab session. In this session, I'm going to deal with another interesting program that computes the NCR for the particular values of n and r. Okay, let us prior to explaining you about NCR, let us deal with a function which is going to be employed for computing the NCR. Okay, so the function is the function that computes the factorial of a number. So consider a function we have fact which accepts integer as argument. Okay, a fact which considers which accepts n which is integer as argument. So this function, after receiving this variable value n, is going to check if n is equal to 0 or n is equal to 1. Okay, so if this is true, then it is going to return 1. As we know, the factorial of 0 as well as factorial of 1 is 1, so it is going to return 1. Okay, and this function whatever we are going to define would be a recursive function. So in the else part we have return n into a recursive call to itself, that is fact of n minus 1. Okay, so this is the function definition, right? So if n value is 0 or 1, it is going to return 1, which is nothing but the factorial of either 0 or 1. But what is this else part? Okay, so let me explain this part. So consider that n value is equal to 5. Okay, then we'll check out with this condition. N is 5. Is n equal to 0 or n equal to 1? No. So we'll come to the else part. So the else part what we have written is return n into fact of n minus 1. So this statement gets changed to return 5 into fact of 5 minus 1, that is 4. Okay, remember one thing, friends, in programming, whenever we return, okay, it should be a complete value. Whatever value we are trying to return, it should be a complete value. In this case, when I say return n into fact of n minus 1, we substitute the value of n as 5, then we get return 5 into fact of 4. But over here, this entire thing is still not complete. Okay, we know what is 5, but what is factorial of 4? Let us consider one more thing. If I write in a function, say return a plus b, okay, if we know the values of a and b, then first the expression needs to be evaluated, then whatever value we get, that will be returned back. Understanding, friends? So if again over here, if I say into 3, okay, we need to know the values of a and b. Until unless we know the values of a and b, this expression is not going to get evaluated, and this return statement is not going to get executed until we get a final value. So on the same lines over here, what is happening is, for fact of 4, we don't know what is actually fact of 4. That will be known only after the call to itself, and the function should evaluate and return something. Okay, and you know that recursive function are those which keep on calling itself again and again till the base condition is reached. Over here, the base condition is this: if it is going to keep on calling itself, this function is going to, the fact function is going to call itself again and again till this n value, the n value which is 5, is going to reach 1 or 0. Okay, so in this case, once again there is a call to fact of 4. So now n value is 4. So for 4, we'll check the condition. Is n equal to 0? Is n equal to 1? No. So Once again it makes a call to itself. So fact of 4 is going to make a call to itself saying what? Return 4 into fact of 3, that is 4 minus 1, that is nothing but 3. So this is the general equation, this is the general, these are the specific calls to return. Okay, next factorial of 3. Now n value is 3. Okay, so what happens? It says return fact of 3 is nothing but return 3 into fact of 2, that is 3 minus 1, 2. So this is once again making a call to itself with n value as 2. So this will get changed to what? Fact of 2 is nothing but return 2 into fact of 1, that is 2 minus 1, that is 1. Okay, now also observe carefully that for every recursive call to itself, the problem is getting reduced. Initially the problem was to find out the factorial of 5. Next it got reduced to finding the factorial of 4. Next it got reduced to finding the factorial of 3. Next it got reduced to finding the factorial of 2. So it is getting reduced by some constant value. Okay, now it is now factorial of 2 is making a call to factorial of 1. So we have written 2 into fact of 1. So when the call is made to itself with the value n as 1, what happens? Let's see. Now is n equal to 0? No. Is n equal to 1? Yes. So this function for the value n equal to 1 is going to return 1. So it means what? Factorial of 1 is 1. So we can do what is factorial of 1 is 1. So we can substitute the value of factor of 1 as 1. Understanding? Now this return function which is available in factorial of 2, this return statement which is available in the factorial of 2 has got some value to return. So this is going to return to factorial of 2. So return 2 into 1, what is the value? 2. So that would be returned to this factorial of 2. That is nothing but 2. Now this factor return statement, that is return 3 into 2, okay, is available in factorial of 3. So when I say return 3 into 2, 6, that would be returned to this factorial of 3. That is nothing but 6. Now when I say return 4 into 6, it is nothing but 24. That is nothing but for this call. Factorial of 4, that is nothing but 24. When I say return 5 into 24, okay, so it is going to return what? 120. So for factorial of n, suppose over here in the main, if there is a call to this function, say fact, say result equal to fact of 5. Okay, then lastly this return 5 into 24, that is nothing but 120 is going to get assigned to this variable result. Okay, then we can make use of this value to print the factorial of the number. Okay, so this is nothing but the recursive definition and its explanation for factorial of a number. Okay, now we know that there is a function. Okay, let me just erase this part. We know that there is a for recursive function fact which is like this, and we have main which is going to make use of this function. Now in the NCR, okay, now let us come to the programming aspects, hardcode programming. Now NCR can be computed as, okay, NCR is computed as equal to n factorial divided by n minus r factorial bracket n minus r factorial into r factorial. Okay, so this is the way ncr is represented, n factorial divided by n minus r factorial into r factorial. Here we know that how factorial has been computed. Only the thing is we are supposed to make use of this function smartly so that we can compute ncr. Okay, so the same thing happens over here. We have the recursive function int fact, okay, which is going to do this. If n equal to 1, n equal to 0, it's going to return 1, else return n into fact of n minus 1. Now in main what we have is, yeah, the variables n and r which represent the various values of n and r, and ncr a variable which holds the final result ncr. Okay, we'll scan the values for n and r. If r is greater than n, okay, remember one more condition, the r should never be greater than n. Okay, so if r is greater than n, then r value, we get a statement saying what, r value greater than n and ncr cannot be computed. So take care that r is never greater than n. Okay, else ncr equal to, we know that there is one function written factorial recursive function. The same function we can use it for, see, as I said, ncr equal to n factorial divided by n minus r factorial into r factorial. So for each of the three times, why to write three times separate factorial functions? Better write once, reuse it again and again. Okay, so for factorial of n, we call this the same function. Then factorial of n minus r, again with the same function. Into factorial of r, again the same function. This is how ncr is been computed. Okay, ncr is equal to factorial of n divided by factorial of n minus r into factorial of r. Okay, lastly we print the ncr computed factorial. Fine. So later on we can do what is, for different values of n and r we can tabulate the ncr value. Okay, tabulating in the sense what we can do, what is, for can tabulate for n and r, what is ncr. Okay, so for n value as say 2 and r value as 1, what is ncr? Then for n value as say 17 and r value as say 10, what is ncr? So we can just create a table, and for different values of n and r we can compute ncr. Okay, so can do this. Now let's check out with the program output. Let's compile this. So gcc ncr dot c. Yeah, it is the program. Yeah, the program name, it should be gcc n capital C r dot c. Okay, dot slash a dot out. Enter the value for n. I'll enter it as say 10. R, I'll enter as 5. So ncr equal to 252. So we can repeat the same procedure for different values of n and r, and we'll get different ncr values that we can tabulate. Okay, so I hope you have understood this program. Thank you, friends.